Well, we're really excited for today because Lajos Turi is coming and he's bringing us a very scientific component, a real engineering marvel. Literally, but don't laugh now, idiot, our rear spring bracket is completely rusted to pieces.
Let's go to him. We're waiting.
This structure is completely shot.
And today Lajos is bringing the raw material from the laser cutting company. And what is today?
We'll assemble it.
Then we'll equip it, and finally our vehicle will be in its proper place. As soon as Lajos enters, the camera rolls.
Let's go to him.
And finally our vehicle will be in its place as soon as Lajos enters. I don't know what this is. Some kind of cradle. We're reducing from the accessory into the spring holder. That's it, spring bracket, man, this sucks. Since I didn't feel like patching it, through our friend Balazs de Berhegi, we contacted Lajos, who usually does things like scanning things, designing things, and having things manufactured. So the thing is, Lajos designed something like this for us, out of several pieces, like what? 2-piece, 3-piece, but this is what we ended up with.
These can't be the 2 or 3-piece ones. In some places it's left a bit thicker.
So yes, this is exactly a 2mm sheet here. I already know that this is some kind of, well, whatever. I can pretty much see what is what, actually. For example, the activity of the nut. And on top of that, you even added a steel nut to your mother, damn it. The guy's watching, so be careful. There are some fancy things here, and well, we're here today because we're going to put this together.
That's right.
Why is it better to design something like this instead of just grabbing it and patching up that crap?
Well, if patching is effective in that particular case, then obviously it's more efficient to patch it. But if there are conditions like with this part, for example,
you'd need more of it.
As a part, more or less. And if it's necessary for the part to be stronger than the original part, then in this case it would be quite difficult to recreate it.
The part is quite complex, so to speak.
Yes, it's quite difficult. It's pretty hard to recover the exact dimensions of such a part and come up with a solution to design a model that can actually be manufactured. From sheet metal with bending, welding, and laser cutting technologies. The first step in such a case is to digitize the part. In other words, 3D scanning. At this point, a machine collects a large number of coordinate points from this part. A point mesh is formed, or more precisely, a point cloud. From this, something is later created. This is already very scientific. Yes. Later, a surface model is created from it, from which you can already make a simplified, reverse-engineered shape in CAD, and later it can be turned into a sheet metal part.
What is the next step after that? Obviously, we might need to agree on a few dimensions to clarify, for example, these measurements, because I think it already got bent when we took it off.
Yes.
And also, the shot blasting didn't help it keep its original shape either.
Yes, in this case, the general reference, like the original part, was there. You could determine its general shape and size. But after that, the adjoining parts that have to fit the rest of the car had to be checked. After this, the basic shape was made, and later the important parts were separated into sheet metal and in such a way that they could be manufactured with a laser cutter and a bending machine.
As we can see the parts, this is not a small thing, as I see it. How many hours of work was this, approximately?
To design something like this from start to finish, it can be done in 1 to 2 days, with 8 to 10 working hours per day.
So that's about 15 to 20 hours, roughly. So that everyone understands, it's not always easier to take it to a metal worker like Vinatu to have him quickly put this part together. Because he'll waste a lot of time on it too, and I'm sure the quality won't even come close to this.
Yes, my experience is what made me start working this way, that at first I also tried to solve things in the physical world. And my experience with it was that a lot of time was spent on these things. And despite the best intentions, the best expertise, and all the time put into it, the end result always left something to be desired. Yes?
Either the appearance or something else, but it's still a little off somewhere.
Yes, and when the physical realization takes much more time, by the time it becomes spectacular, it already shows. The component helps form an overall picture, letting you assess if it was successful.
This could have perhaps been improved even more if the calcite had also turned out nicely for you.
That's right.
And then basically I would have tried.
As much information as possible. A given component doesn't necessarily reveal how the surrounding components are positioned, how far they are from it, what they cover, or if they will get in the way later. This component, since it was basically the only component available for this project, had to be modeled as accurately as possible to match the original shape.
This one even still has the spray paint on it that you used to coat the original part. Alejo scanned it. It's made up of 3 parts, and I've already welded it together. This is pretty much what it looks like when it's finished. You know, for the S13, for example, this is a relatively weak point. These always tend to bend. He writes, he reads, so the difference is huge. This paint, if I know correctly, is on it because it really helps you with the scanning.
Yes, this is a matting spray, but it's more about preventing reflections because then the scanner would pick up false data.
Actually, this part was here at just the right time because I only welded one of them together, so on Wednesday.
Thank you very much.
I'll clean the workbench, then we'll assemble it.
Oh, the glass maker, right?
Very good.
I'll install the scientific plate.
Right? Of course, if they didn't turn it, it would be fine. That's it. We have a 17 ratchet if you drop it.
Do you want an extension too?
Yes, I'm curious.
Okay, long. It will be long.
I already let you know. No. Hey! It fits here too. Damn, it's really fancy. Would you like to take a look? Everything. It's installed. Nothing had to be forced. Really fancy, isn't it? Yes.
This will be good.
Interesting sounds. You've heard something like this before, right?
Yes.
You usually make cars that make sounds like this.
Yes, when the car looks like a coffin, then oh ho.
Wood! Let's take it off, and I think let's just slap the rest of the little thingamajigs on it. Hello. Can you take it? Well, it's more jumbled.
What kind of face should I make?
The natural face.
My face looks so unnatural. How can I fix this for you? Length, 911 May. Do you believe it's accurate to the millimeter? That's what we would have been, but...
Is this how the last details get sorted out? Or something like that. We need to take out a Facom tool. It's a bit dirty.
But yes.
Because it's a Facom Dormy. It doesn't wash. It doesn't wash. Stay there, those ones. Almost. We're pressurizing our welding goggles.
I can weld it in there so well.
Perfectly. In fact, I think we can just let this go. It didn't even get to that point, so I can give this some amps, right? I think I'll take a look at this arc with about 46 words because still. You're nice and green. That's right, I have ties because of my connections. I think it turned out excellent. I put it into the structure and I can go anywhere with it. Uh-huh.
I don't know.
It will need to be adjusted.
Nicely. I'm sure about it.
Thank you very much.
Grab it. There's a difference, but it's minor. There is, but I had more in mind. Chaba, then tomorrow.
Thank you.
We put together your wedding, including the island for the ceremony. What? How did you put the spring in? Next to it? Oh, okay, quick number.
Thank you. I'll tighten it as well.
It's tightened. Perfect. Okay? I'm already checking that it's up. If there's a problem, I'll cut it out. So we have some left like this. Thank you very much. He knows how to look over there. Very fancy. These two bad pieces here will be a pint. Thank you very much, sweetheart.
Butter!
Monica. And the narrower part is the front. Beautiful. What am I thinking about? Well, I'm thinking that I should put it on wheels. I have to put this up. I have to bring the water up. So you can do it, yes. To put those... Here's the car. Why? I couldn't take it off. So this thing is lighting up on your car. That's cool. I really like it. Ah, why is it visible?
Thank you. Thank you very much.
Now please hold this here, that half, and a bit lower too if you can manage. With what? Oh, right. It stops here. This will still hold. This is the paint. Now my new fingerprints will stay in it forever. Extended family. A collection of all bad thoughts. Listen, what would be the catch? Which one? You just can't really lean on it. Yeah, now we need this side. Ready? Go ahead, go ahead. Seriously, Mooley. Oh, got it? Okay, let it go. Thank you. Well, this is amazing. Thank you. May I bring it in? Take the lamp out of there, and then yes, you never know if anything will happen. No. Well, this is kind of off-road now, so the spring was sprung. Yeah, it spent a good 2 months on the ground here. Okay, the back is hard, no soft, hard. Bit hard. Lajos has left. Lajos was here because he brought a scientific suspension bracket, which we also installed. Look at how fancy it is, what a classy piece. So let's say the suspension area bodywork is done, and next we'll be installing the engine. We'll put the engine in with a tiller, and we're going to perform a heart transplant on our little Serena Gomez.
SRMINATOR. SRMINATOR.
So kids, next time engine. Bye.